Hello and welcome to SDN Tech Forum. This is another video in SDA tutorial series. In this video, we are going to discuss about Anycast Gateway and DHCP in SDA environment and how they work together. A disclosure is, in this video, we may talk about a little bit of Lisp concept. If you are not familiar, watch my other video on Lisp and also on DHCP. But if you haven't watched that, you can still go ahead and watch it and things will be very clear when we walk through the diagram. All right, so let's get started with the agenda. Agenda is DHCP in SDA. What is different? What make it unique, right? Then we walk through the flow diagram, process flow diagram, and it will make things really clear for you. Then we'll have a process walkthrough and we will look at the configuration level also. Since most of the configuration is automated by DNAC, but it is still very interesting from a network engineer perspective to understand the CLI configuration and know the secret sauce. Then we'll look at the debugging and also finally I'll show you option 82, how it is encoded and how we can decode it, right? And obviously at the end we will do a demo. So why DHCP is so different or so unique in a SDA environment? Generally DHCP is very simple, right? So DHCP is a little unique because our SDA Fabric, our SDA is a fabric where you are using Lisp as at the control plane and VXLAN at the data plane, and you have Anycast Gateway configured on each and every access switches, Fabric edge switches, right? And DHCP server is reachable via border. And between border and edge, it's all Lisp based control plane, right? It's no traditional routing. Obviously there is a routing, but that is in underlay, and that's just for VTEP connectivity or RLOC connectivity, but control plane is all taken care by Lisp, right? So let's understand the problem statement. In SDA, DHCP Anycast is on Fabric edge. Again, I'm repeating, but DHCP server reachable via Fabric border. Therefore, some additional consideration required. And also keep in mind that Lisp is a control plane. That is why some additional consideration required. So what happened? Edge has a proxy ITR and default map cache configured. These are Lisp related terminology. So my edge should be configured as proxy ITR and a default map cache should be configured on it. This two line of configuration allow my Fabric edge to process the DHCP request or any DHCP packet, sent it on overlay, not sent it on underlay, but sent it on overlay. Also a regular configuration, as a regular configuration, DHCP relay is configured on gateway. Since my DHCP server is sitting outside my local subnet, so obviously you need a DHCP relay that is configured on HBI. We will see when we look at the configuration snippet. DHCP uses option 82 field. This is very important, and this is kind of like a secret sauce for DHCP implementation in SDA. So we are using option 82. Option 82 allow my edge to encode RLOC IP address and VNID information. This information is very important for DHCP server to select the address pool and my border to send the DHCP reply back. You will see it more when we walk you through the diagram. DHCP snooping is enabled on switch, right? When DHCP query arrives from edge, DHCP query, when it is received on edge, sent to the border then send it to DHCP server. However, for DHCP server to reply back, it need a route back. But again, since control plane is Lisp, host is treated as /32 route, and it is available in the host table, but it is not possible unless you have DHCP process completed, right? So it is like a chicken and egg problem. To solve this problem, border has same SVI IP address defined as loopback, and this is pretty unique, right? Nowhere in traditional network we have same IP address used in two places unless it's Anycast, but here on border you have a the same SVI, same IP address as of your SVI configured as a loopback, so that border has this route locally, and then you advertise this subnet outside, right? So if you have route in your route table, then only you can advertise, and that's why we have a loopback IP address defined, and we advertise it outside. So by doing that, DHCP get the route back. Okay, DHCP server get the request and look at the GIADR. So it looks at the relay IP address, and it picks the right IP address pool and allocate a IP address for the client. Border receive the DHCP reply. It looks at the option 82 field, and I will show you what is there in option 82 field, and then looking at the option 82 info, it relay the reply, DHCP reply back to the Fabric edge. Fabric edge, since everything between border and edge is encapsulated in VLAN, it actually de-encapsulate it and forward the reply to the client, and then the client in turn get the IP address. Okay, now let's watch this thing in the diagram. So DHCP request flow, what happened? So I have wired .1x client connected. When it comes up the first time, it sends DHCP request, nothing new. Okay, and it hits a port. If it is a .1x authenticated port, you actually authenticate first, and then your DHCP thing come into picture. So imagine or assume you have already authenticated. Then what happened? Unicast, this switch listen to that DHCP request, then it unicast this request to border. Why? In overlay. Why? Because those two configurations are there, like 0/0 map cache and proxy ITR. So it knows that I have to send it on overlay, and since I'm using option 82, Fabric Edge go ahead and encode its RLOC and VNID and set the GIDR as SVI. Okay, so whatever the VLAN this port is part of, it set the SVI GIDR as SVI. Okay, so far so good. Edge has done its job. Then what happened? DHCP request sent to server. So border received that packet, and it then send DHCP request to the DHCP server, since it has the reachability. Now what it does, it set the loopback, its own loopback as GIDR, which is actually not different. This SVI and this loopback 3000 something, they actually are the same same IP addresses. Okay, so my DHCP server get the request. Okay, now what happened? DHCP reply flow. Now DHCP reply is sent to border. DHCP address look at the GIDR, it select the address pool. Okay, and then it send the reply back to the border. Okay, that this is your client IP, and it send it to the border. Then border, when the reply comes to border, DHCP reply investigated for option 82 to find RLOC and VNID. So border switch looks at DHCP reply, especially at option 82 field, and it get to know what is RLOC and what is the VNID, which is list instant ID, and based on that it does a lookup and send the DHCP reply back to edge. And obviously that reply is again encapsulated in VXLAN format, because everything between border and edge is VXLAN encapsulated. Fabric Edge receives that, it know that which it is intended for, what RLOC, obviously its own RLOC, but it looks at what VNID. So it know that this is designated for such and such VNID, and then it de-encapsulate that VXLAN packet and send it to the port, connected port, and that's how my client receive the IP address. So now you can see that it has received an IP address. So this is pretty simple, at the same time very unique process, right? So again, one more recap walk, how it happened, whatever we saw in the diagram. Client sends the packet. Step 1. Edge received DHCP from client on a certain VLAN port, assuming you have authenticated or you have .1x authentication. So you authenticate and get a part of VLAN. Then Edge forward unicast DHCP request to border with option 82. Option 82 has Edge RLock RLock and instance ID and GIDR set to Anycast gateway, right? Edge should be proxy ITR and configured for 0/0 map cache, and VLAN snooping is enabled on all Fabric VLANs. Okay, so Edge has done its job, set the option 82 and send it on overlay. Request arrive at border. Before it is forwarded to DHCP server, it has to be give a DHCP reverse path. The same thing what we discussed earlier. Anycast subnet is not in Lisp host database yet. So as a workaround, border has same Anycast IP address configured with the loopback 3000 range. Okay. Advertise this VLAN as a network, and these things will be more clear when you look at the configuration. That's why we will actually go and see what is the configuration, device configuration look like. This loopback have a DHCP border relay configured, so reply from DHCP comes to this address. Now things is simple for DHCP server because it know the GIDR, and based on that it select the address pool and it has the route back to that GIDR. So for DHCP things are simple. DHCP reply comes back to border. Border does have this GIDR locally. It is punted to CPU to investigate option 82. Under option 82 you find RLock and you find instance ID. You use this information and send it to Fabric Edge. Fabric Edge, obviously this reply is encapsulated. Fabric Edge de-encapsulate it, look at the instance ID and send it to the client. So this is the entire workflow, right? Now let's look at the configuration. Within configuration, one thing I mentioned earlier that the map cache 0/0 and proxy ITR should be configured on Fabric Edge. Also, you need to consider that the DHCP server itself should be reachable from edge switch, Fabric Edge switch, via a specific route other than default route. So what I mean to say is, let's look at my SVI configuration. So I have my SVI configuration. This is Fabric Edge configuration. So it's a Cat9K switch, and this is my Anycast gateway configuration. Interface VLAN 1022. This is part of VRF campus VN. This is my instance ID, and you see the helper address is 105. This is actually my DHCP server itself. Okay, and this DHCP server should be reachable by a non-default route. So that's what I would like to show you here. If the show IP route on my switch, which show you that I have a default route, but I have a specific route 60.51 here as well. Okay, so you have IP address, and this is the Lisp configuration. Based on how many instances or how many address family you have configured, you may have multiple configuration, but this is this is a configuration snippet only for one particular user space. So router Lisp, this is my instance ID, and this is my dynamic key ID. That's the subnet actually, and you can see that map cache 00 is configured here, right? For Fabric border, you can see I have a loopback configured 1025, which has the same IP address as of my VLAN IP address, right? Obviously I picked the wrong VLAN. I should have another VLAN 1024, which is an IP address of 91.1, and that's the same IP address you have here. Okay, and since I have a loopback defined, I'm actually advertising it via BGP, since I'm running BGP between my border and Fusion router. So this is how the configuration snippet look like. Okay, let's look at some debug, right? What you can do to capture this debug. Look at the debug command. You can run your so all Cat9K, they have embedded wireless Wireshark running, sorry, not wireless, Wireshark running, and that's where you can run your monitor capture. So you can run monitor capture on your interface, on border and edge, and if you do that, this is the log look like, and this is on Fabric edge, not on border. So you can see, since I have DHCP snooping enabled, receive new DHCP packet from input interface 1024, process new DHCP packet, message type DHCP discover. So it has received a DHCP discover on this interface. Some details around that. Destination address is broadcast, MAC address is the MAC address of virtual machine, layer 3 is all broadcast 00, and if we are not familiar with CIDR, YADR and GIDR, watch my DHCP video, okay? And obviously the VLAN ID, because the port where you receive this packet is already authenticated and assigned a VLAN. Okay, so what happened when you receive the packet? Add relay information option, and look at this, encoding port option 82 CID circuit ID as VLAN mode port format, and you will see more on option 82 in when we start looking at the demo. Okay, and this is what it did. So in how it encoded option 82, it encoded option 82 like this, and I have color coded it these fields because every field means something different. Okay, and we will encode option 82 in our Wireshark format. All right, so I'm going to run a demo, and we will come back to this slide because it is much easier to see it from here rather than on DHCP server or somewhere. It's easy to look at the screenshots. Okay, let me go to the switch one more time so that you know that yes, we do have show authentication. So this is my Fabric edge where I have a Windows machine connected, session T1024 details. You can see that DCA4 MAC address is getting IP address of 91.14. that means DHCP is completed, and .1x is authentication success, right? What you would like to do is show IP DHCP snooping binding, and you can see that VLAN 1025 is assigned, and if I show you show run interface VLAN 1025, this is how it looked like. So as a part of campus VN and having an IP address 91.1. okay, show run section router Lisp, the same thing what I showed you on the, so you can see that the instance which is of our interest is 40 map cache is configured, and this is the instance ID 4099. Okay, so just keep in mind 4099 and map cache is also configured. Okay, so I have shown you the Lisp configuration, the Anycast gateway configuration. Now verify some things quickly on border. There is only two things you would like to see on border. I have already shown you that in the documentation. Show run and you can see that 172.1691.1 is my loopback 1025. So I have the same IP address configured as loopback as of my Anycast gateway. Okay, now I wanna go to the client and server itself where the DHCP thing is happening. This is my client. Let me log into my client. Sorry about the noise, a little bit background noise. Okay, what I want to show you here is the IP address config, and you can see 91.14 is configured. Even if I give up this, say release and renew, it is going to actually trigger the DHCP one more time. And let's wait what IP address it is going to get. Most probably it is going to get the same IP address, because DHCP server always give you the previous IP address if it is available. So you can see that same IP address is available. And now let's go to the server. Okay, this is my DHCP server running on a Ubuntu machine, and I have already ran a packet capture. So you can see 172.16.91.14 coming to DHCP with DHCP request, and this is the thing. But instead of looking at here, I have taken a screen capture, and let's go and check it in the screen capture. Okay, so this is my client host. Its name is VQ. Just look at the VQ. So what is happening? Internet Protocol version 4 and source IP is right now, you can see is 91.1. that is my GIDR IP address, or on border, right, or any cascade IP address. It's sent to there, and then you have UDP for layer 4 information, source port, destination port. But what we are interested in is in Bootstrap protocol, right? So Bootstrap protocol, right now the client hasn't got any IP address. That's why the client IP address is all 0. And I have a relay agent configure, that is my SVI itself, right? So Anycast gateway itself, that is my relay agent. And this is my client Mac, the Windows machine, the virtual machine, right? So let's look at option 82. Sorry, option 82. Since when I expanded the option 82 and taken a screenshot, it looks like this. It has 2 fields. Okay, option 82 sub option 1, option 82 sub option 2. Option 1 is called agent circuit ID, used to identify the VLAN and individual switch port. Okay, how? I will show you. Option 2 is called agent remote ID, identify Lisp instance or VN ID, or so Lisp instance and VN ID are the same thing, and RLOC, which is your fabric edge. So how it is encoded? Just take a note of agent circuit ID ends with 118 and remote ID ends with D45. So first we will decode circuit ID, which ends in 118. So you see 00 is sub option 1, that denote the encoding is in VLAN, mod and port format. And then next 2 bits are length of option. Okay, then in the third field 4 bits denote your VLAN. So if you use 0401, so this is hexadecimal, right? And I'll show you. You can simply use any online converter. Okay, so you can use any online converter to convert from hexadecimal to this. And let me use a incognito window, pull it here quickly. Hexadecimal. Okay, hexadecimal to IP address. No, hexa. Okay, this is good. So 0401, that's encoding, right? You want to know what is the VLAN. 0401, just say convert, and you can see 1025, that is my VLAN, right? Then you have 01, which is module 1, and finally you have 18, right? So let's see what 18 gives you. And pardon the advertisement on the right side because it's a online website, so you can expect advertisement, but see 18 equal to 24, that means module 1 port 24, right? So that's how the encoding happens. So now let's talk about remote circuit ID. Again, a hexadecimal field. 03 says it's a Lisp sub option. 08 is a length of that, and then 6 digit to define Lisp instance ID. Copy it, and we're going to put it here. You can see 4099, that means it's Lisp instance ID 4099. And finally you have rlock. So rlock, this is the hexadecimal value, but it is actually encoded in IP address, right? So if you convert it to decimal, it may not make much sense to you that what is this rlock, right? So what you want to do, you want to convert it. Okay, you can have hexadecimal to IP conversion this time instead of decimal. So you can go here in another website and just say convert to IP address, and you can see 192.168.13.69. So what we get from this decoding, you got port number 24, VLAN 1025, and instance ID 4099. rlock is 13.69. Let's verify on our switch, going back to switch again. So show run int loopback 0. You can see this is my loopback 0 used as rlock IP address, and show run int VLAN 1025. This is 91.1 and VLAN is 1025, right? And if you want to see where this VLAN 1025 EID is binded in Lisp. So instance ID 4099, it has my EID prefix, right? So that's how option 82 get encoded information from any CAS gateway, information from Lisp, and rlock from your loopback, right? And that's how things move from Fabric Edge to border to the DHCP server. DHCP server processes that based on the GIDR, send the information back. Border process again use option 82, send it to Fabric Edge. Fabric Edge remove the option 82, uses the VNID information to pass on the DHCP reply. So that's how it works, and I hope things are much clear in your mind now. And this is a unique proposition, and I think it's very unique or a intelligent job it has done in programmable Fabric, and I hope you understand it better now. So thank you very much for watching.